Hey guys, so here is the circuit that I've been trying to get back online here. I rebuilt this circuit, and basically it's a really simple braking MOSFET circuit. It uses two MOSFETs. It uses an N-Channel MOSFET and a P-Channel MOSFET. At the end of this video, I will show you a couple of schematics based on this circuit, or that this circuit is based on, actually. So basically, what we're doing is we've got a simple little motor here connected through this circuit. We've got our battery source over here. We've got a switch. The switch is connected to the N-channel MOSFET, and it will activate the MOSFETs upon pressing the switch, and then when the switch is released, the circuit automatically breaks. And unfortunately, I don't fully understand how this works. I just was able to get it working. So anyway, if I go ahead and push the switch, I'll push the switch and release it a few times, and you can see that it is indeed breaking. So works pretty straightforward. In the past, I talked about having some issues with burning out MOSFETs. These MOSFETs are rated pretty high, and once again, I don't know enough about how all this works, but there's a couple issues. Last time I was testing this, I was testing it with a LiPo pack. I tested it with a 2S LiPo, and it seemed to work fine. And I tested it with a 3S LiPo, and it worked fine a few times, and then one of the MOSFETs blew. And I've blown quite a few MOSFETs with this circuit on a 3S. And they don't seem to be overheating. I just don't, so there's something about the circuit or the load, and I don't know. I think it has to do with the braking, because I've used 3S with just the N-channel MOSFET, and I was able to run a pretty powerful motor with 3S without braking. So introducing the braking seems to introduce a whole different set of stresses on the MOSFETs. Once again, I can't really explain it, but maybe somebody else out there could comment on that. But for now, this is a pretty straightforward braking MOSFET circuit, and if you don't overload it, it will. It seems like it'll work. I haven't really stress tested it yet. That's next. I'll be putting it into a Nerf blaster and with an actual with a LiPo, and see how it behaves. I also have a couple other MOSFETs that I'm going to test out that are higher, that will allow higher current draw. So I will be making another video soon with the other MOSFETs. And that's about it. I've got a couple of schematics, so I'll move this circuit out of the way, and I'll show you the schematics. So this was the original schematic that I found online at an airsoft forum, and the forum, the pictures are gone now. The guy had a really cool kind of like an instructable on how to make braking MOSFET circuits for airsoft, and his pictures are no longer available. So this was one I happened to have captured, and it's pretty much it's pretty much the exact circuit that I created on the breadboard. This couple of things to note here is I added the diode. He didn't have a diode in his circuit, so I added that. The other thing to take note of is that these connections, let me make sure I read this right. So the battery, he's got the battery going to the switch. That's the same as what I've done here, the positive side of the battery. The negative side of the battery is going, oops, right here, is going to the source of the N-channel. So this is a little confusing here. You can't really see it in the diagram, but some of these wires overlap. Some of them connect, and some of them do not connect at these junctions here. I have a schematic which I created, and I believe this schematic here is the same circuit. I'm 99% sure it's the same circuit as the one I just showed you, and it's the same as what I breadboarded. And you can see here it's a little easier to see where the wires intersect or where they shouldn't intersect. And you can also see the exact MOSFETs that I'm using. So that's it for now. If you have any questions, leave comments, and thanks for watching.